Okay, so advanced chem students, this is going to be a demonstration of your electrolytes and non-electrolytes demo lab or lab. So if you'll get this paper out, if you don't have it, go ahead and print it. But you're going to write all your data here on the front and then answer the questions on the back. Let's get started. So I've got a list here starting with 5% NaCl solution. And what I'm going to do is take a conductivity probe that when I place it in the solution, it's going to change color. So it'll light, it won't change color, but it'll light up when I have an electrolyte present. And I'm actually going to turn off the lights. You know what, I'm going to leave the lights on. Let's leave the lights on for now, and if we have some that are really dim, maybe we can zoom in or turn the lights off at that time. We'll see how it goes. So 5% NaCl solution. So I'm going to place it in the solution, and then you're going to watch it and tell me what happens. Yeah, I can't hear you. So I'm guessing you said it lit up. So that means that it's an electrolyte. So the electrons are being transferred from one terminal to the other terminal through the solution. Are you going to close the door? Okay, like this. Yeah? So if it is very bright, it would be a strong electrolyte. And if it is weak, it would be a weak electrolyte. If you don't see any light at all, it is a non-electrolyte. And so that's what you need to write on your paper, where it says observation, bright light. If it says comments, strong, weak, non-electrolyte, for this one you would write strong electrolyte. For the rest, I'm going to kind of go through here pretty quickly, rinse off in between, and if you need to slow down or whatever, just hit pause on the video, and that'll be that. Okay, so the second one I believe is distilled water, and I may get my laboratory assistant to come in kind of close and take a look at this one, but this is distilled water. And we'll place it in the solution. Michael, can you turn off the light back there real quick? See if you see anything lighting up there at all. Do you see any kind of, maybe just a tiny bit?
No.
Okay, will you turn the lights back on? So, distilled water has a little bit of ions in solution. You would know not to, be exposed to electricity and stand in a pool of distilled water. I'm sorry, distilled water would be fine, my bad. It's tap water that would be different. We're gonna have to do this again because the next one's tap water. Wow, this is one of my best videos ever. Okay, so if I come along in here, actually, I don't know if, can you see it in there?
Yeah.
Yeah, you might see that the tap water is actually just a tiny bit. The distilled water should not have done any conducting of electricity. That's my bad, guys. So yeah, that would be the salt solution, the distilled, and then the tap water. The next one is solid sodium chloride, so this is salt as a solid, and if I take it and place it in the solid salt, you don't see anything. These ions are not free to move. This is not a solution, it's not dissolved in water, and so you won't see. You'll see it'll light up a little bit over here as I start to dissolve those ions, but no, you really shouldn't see one with a solid. So that should be written as a non-electrolyte when it's a solid. The next one is 5% sucrose solution. So this is table sugar that I'm going to do next. If I place it in that sugar solution, there's nothing. Actually, that's a lie. It's lighting up a little bit. I think it's contaminated. Anyway, nothing for the sucrose solution. So I'm going to take that one and rinse it off. After the sucrose is kerosene. So kerosene is actually a mixture of a bunch of nonpolar compounds. If I place it in the kerosene, there's nothing. No light there as well. The next one is it 1 molar hydrochloric acid. So hydrochloric acid is HCl. It is a strong acid. You guys will see if this actually conducts electricity or not. It does. If I take it out of the hydrochloric, do a little cleaning, the next one is 1 molar sodium chloride, which is a strong base. Put it in the 1 molar sodium chloride, sodium hydroxide. There you go. Let's see, after sodium hydroxide is glacial ethanoic acid. So what it means, glacial, is that this is pure ethanoic acid. And so what we're seeing is, I believe the concentration is 17 molar. It has very, very little water in it. should see, and it's really stinky. Doesn't have very much water in it, and it is a weak acid. So what we see is nothing. Doesn't light up at all. Now that's 17 molar or glacial acetic acid or ethanoic acid. They mean the same thing. The next one is 6 molar, so this one has some water in it. And so we might see something a little bit different. You may have to get close on this one to see it. I'm not sure. So this is 6 molar ethanoic or acetic acid. You might even have to look in there and kind of see that that one is lighting up a little bit. It's the same acid, but this one has a little bit more water in it, and so it's actually able to ionize. Washed out. That's stinky. After the 6 molar ethanoic is 6 molar ammonia. So this is 6 molar NH3. This one is a higher concentration than the next one I'm going to do. This one is 6 moles per liter. The one I'll do after this is only 1 mole per liter. We'll see if we notice a difference between the two. It's difficult to see if there is, but this is 6 molar ammonia. You might be able to see that that's, can you see from there? I'm not sure. That it's lighting up just a little bit. That's 6 molar ammonia. Now I'm going to put it in 1 molar and see if we can tell a difference. I don't know that we will be able to, but we'll try. But that one was weak. This one is a lower concentration.